I've been saying for quite a while now that you have to remember that the compiler has to allow the possibility of subtypes because maybe a class or interface hasn't been written yet, or the compiler simply hasn't encountered the code yet, something like that. Now, the question is, why does it still allow this possibility when the class is marked as final? And here's a little setup to illustrate what I mean. Now, what we've got here is final class there, and this generic class gn with a type parameter t which extends s. So that allows very little possibility. And here are some parameterized types to illustrate what I'm talking about. We got the usual extending s, the wildcard form, super s, and just the s parameter by itself. Now it turns out, if you look at all the possible sets, that they've all got the same type in it. They're all basically this, gn of s. And yet some of these types are not compatible. Now, you can do things like test of xs, which is the extend s form. That can be set to the super s form. So obviously the super s form is a subtype of that, but it doesn't work the other way around. And in fact, if you look at it, the thing divides up into two types. You've got test of the xs, the extends form, and the wildcard form are basically the same type, and test s and the super s form are basically the same type as well. But these two are obviously incompatible. So the question is, why is that? Why does it ignore final? Because effectively that's what it's doing. Well, it works something like this as far as I can see. Having found one type which is applicable, namely s, the extend form, like that wildcard extend form, allows the possibility that s may have subclasses. And because of that, it means that it's not going to be equivalent to the wildcard super type. Now, if it had not found any type, of course, if it had not found the s or anything like that, then marking the class as being final, s being final, of course, would give an error. So we've seen that type of error before. I've already mentioned that. So why is that the case, that it doesn't allow these two types to be effectively the same, even though they're basically using the same set? And the answer to that, or at least one of the reasons why it can't allow it, is something called binary compatibility. And this is a rule. There are several rules, and one of these rules is that changing a class which was declared as being final to no longer be declared as final does not break compatibility with pre-existing binaries. Okay, now what that means in effect is that if we were to go and change this class from being final to no longer be final, then it must not break compatibility. This must still work. This other class has still got to work. This other binary here which gets generated, this other class here, must still work just as before. Now, pretty obviously, if we were to lose that final, then of course the super case and the extend case wouldn't be the same, because the extend then would definitely have to allow the possibility of there being subclasses to s, and that would make that would definitely make that fail. So that's why it's this rule on binary compatibility definitely rules that out. Obviously, going the other way is going to break binary compatibility if you think about it. Suddenly declaring a class to be final will break compatibility, but going the other way, changing it from being final to not being final, should not break binary compatibility. In fact, must not break binary compatibility. And for that reason, super is never going to be the same equivalent type to extends. Or except, of course, in the degenerate case. Degenerate case being extend object being equivalent to the super null type. although you can't actually write super null type down. So that's a little beside the point, I suppose. But if you could, they would be equivalent.